So we're starting to get into some pretty cool algorithms here with the selection sort. So like the ones before, the selection sort is trying to essentially fill each space, if you will, in the list. So it starts off with the leftmost, the lowest space, and it's going to set the location of that one. Let's just assume that one's the smallest. And it's going to search through all the rest of the list until it finds the smallest value. And it's going to, if any other value is smaller than that value, it's basically going to set that to be the new index. And after it's looked through the whole rest of the list, it's going to bring that lowest value down to the smallest space. And it's going to go to the second one and do the same thing over again. And so it finds the second smallest one, then the third smallest one, then the fourth smallest one, and so on and so forth. So this strategy is very similar to the other ones, but it uses significantly fewer swaps along the way. It only swaps basically one time for each space. So let's take a look at this one in action. So again, we said the minimum space, not the value, the minimum space is at 0 right here. So that's the this little yellow box up top. And we're just tracking this index for now. So I start my I index, my outer loop at S, my inner loop I start at O. There's no reason to start at 0 because I need something to swap against. So is O less than S? Well, yes, it is. So my minimum index now goes to B1. And then J moves up. Is R less than O? Nope, it's not. Is T less than O? Nope, it's not. Is I less than O? Yes. Let's make the index 4. What about N? No, it's not. G, well, G is lower, so make it the index 6. And then F, yes, F is definitely lower than G now. And so now index goes to 7, 8, 9. We check all the way through. We're at the end. And so I switch, I swap out F up front, and S just goes somewhere into the back. Now, we don't know that S is at the right spot, but F definitely is at the right spot. Then I do it all over again. I jump up to the second one here. I goes to 1. J goes to I plus 1 at 2. And okay, so R's not less than O. T's not less than O. I is less than O. So again, move that to 4. N is not. G is, so move it up to 6. Then the rest of them are lower. So then I switch out G and O. I move up to the next one and follow that cycle over and over again. So the selection sort is, once you see it in action, it's fairly intuitive. It you basically you're doing a series of finding the smallest, finding the largest, which is something we've seen before, we've done before. But then we are looping within that to add that to the sort. We just repeatedly find the smallest value and move it up. It's the exact reason why we have the heap, and the heap data structure is so we don't constantly have to look for the next lowest value. It just automatically bubbles up. But this is a way of doing something similar to organizer list. So if we look at this, it's a lot of searching through the list, but very, very few replacements. The replacements can be expensive commands, sitting there and moving those values around because there's multiple steps inside of there. And so the great part about this is the order doesn't really matter. I mean, if the list is the first item, then great. But regardless of whether it's ordered one way or the other, it's still touching almost every single item that comes through here. So the benefits here is it definitely seems to be a little bit quicker than the other ones we've seen before, but it isn't massively quicker. It's leveled out a little bit. It's not as slow as the other ones, but we're not getting into really, really big gains of how we can have some of the clever algorithms work on. So that's why we have to keep searching. It's a good tool. We can talk about this tool, but there's also ways to get really clever and do it better. So go off and build this one. See what the code looks like. Get this pattern stuck in your head by knocking out the code, testing the code, making it work. But then be ready because we're going to see a really, really clever one next to kind of wrap up this initial set of simple ones. So I hope you knock this one out and are ready for the final one, the shell sort.